Can I prove that 2 equals 1? Well, let's see. Let's say we start by claiming that A is equal to 1 and B is equal to 1. Now, obviously, A is equal to B. If I multiply both sides of this equation by A, on the left-hand side I get A squared, and on the right-hand side I get AB. Now, if I subtract the same thing from both sides of the equation, it still should be a valid equation. If I subtract b squared from both sides, I have a squared minus b squared on the left, and ab minus b squared on the right. Now, the left-hand side can be factored because that's just a difference of squares. It factors as a minus b, a plus b. The right-hand side also factors because there's a common factor of b. So you take out the common factor of b and you're left with a minus b. Now there's that common factor of a minus b on both sides. So if I divide both sides of the equation by a minus b, so I'll divide the left-hand side by a minus b, and I'll divide the right-hand side by the same a minus b. Then clearly I can simplify the left-hand side, and I can simplify the right-hand side, and I get a plus b on the left and b on the right. Well, a is equal to 1, b is equal to 1, and therefore I have proved that 2 is equal to 1. QED is a little Latin phrase, quod erat demonstrandum, which stands for that which was meant to be proved. So I've shown that 2 equals 1. Now, you know, hopefully, that 2 is not equal to 1. So what's wrong here? What have I done? I've actually got a t-shirt with this proof on it, and I think of all the t-shirts I own, this one generates the most questions and the most stares when I wear it out in public. Let's take a look at this proof line by line. So we start with a equals 1, b equals 1, therefore a equals b. You can start with actually any number, it doesn't really have to be 1. The second line after, or the line after a equals b is a squared equals ab. All I've done is multiply both sides of the equation by a. No problem. The next line, where I subtract b squared from both sides, again, no problem. Factoring is certainly no problem. I'm just rewriting exactly what's above it, but in a different way. But let's take a look at the line where I divide both sides of the equation by a minus b. Since I've got a line earlier in this proof that says a equals b, even if I didn't have the a equal 1, b equal 1, a minus b would equal 0. And so I'd actually be dividing both sides of this equation by 0. At that point, the left-hand side would be undefined and the right-hand side would be undefined. And as I've said many times, you cannot say that something that is undefined is equal to something else that is undefined. If you do, you end up creating nonsense. And you can see very clearly that after that we have nonsense. 2 is clearly not equal to 1. And this is really quite a serious thing that you have to watch out for. You have to be very careful that you don't end up dividing by 0 somewhere in a calculation or a complicated proof, because really then after that point everything is just clearly nonsense.